You know exactly. I mean, no lah. If they rush, you know that the exam is coming and they don't have enough time. Okay, come. Let's look at electricity. For you, Jingxuan, I believe you only have two formulas. Yeah, what are the two?
V equals IR.
Uh-huh.
And yeah, I don't know.
Hey, do you need to work out the total resistance?
Oh yeah, total resistance.
Yes, right. Parallel and series, right?
Series just add, but parallel you need to make it question.
Yes.
Then you make it back. Then you flip it around.
Can I think? You know what he's talking about?
Right.
Then in that case, actually you have one more, but that one is a very minor one. So anyway, I write down just in case anyone doesn't know what I'm talking about. Okay, V equals to IR. Of course, make sure you can manipulate this equation around. Then the next one is total resistance. Okay, so this one is, yep. Okay, yeah. Okay, so this one is for series. And to refresh your memory for parallel, you have to deal with fractions. But for you, both of you expect your circuit to be a combination of series and parallel. Okay, Jingxuan, for you, there's one more here for me as well, of course. All right, that is the cost of electricity. Okay, basically the power. The only thing to be careful of, make sure your power is in kilowatts. Okay, multiplies by usage. Usually in a month, but depends on your question. It can be a week. Make sure your usage is in hours. And of course, the rate of electricity given in the question. Now, most of the time, I think they will follow the Singapore standard is about 20 cents per kilowatt hour. Okay, this is the average cost in Singapore.
The formula during exam.
I mean, all this.
The third one.
No.
Oh shit.
No, they were. You're supposed to remember. But for me, you have how many more? I think maybe 4 or 5 more, right? First one, power. Can you remember?
Oh really?
I squared. Mm-hmm. Mm-hmm.
V over 2.
3 squared over R. One more. Yeah. 3 right there. Okay, come, Jingxuan, tell me units for volt, voltage. Units for V. Units. SI units.
Yeah, volts.
Yeah. I
I is
I is current.
current is ampere.
What's the symbol?
Right?
Units for R. Okay, make sure your symbol is correct. Make sure you remember this as well. How many units for power? There is actually one more formula for you, me. Energy what? Over. Why is it this one? Now, the easiest way to remember is starting from here. Now, go back to this first formula. I can also express I as V over R. Okay, so therefore, I put I as V over R. You multiply by V again, and that becomes V squared over R. That's how I got this one. Now, same thing, I can also express this V as IR. So therefore, I times IR, which gives you I squared R.
So for this one, right? In case next year, this one, right? If you want to find power, you have to use all of it.
Oh no, you have to choose one. You have to choose the correct one, depending on your question.
What's
E, E is energy. Help me, units for energy. Time. Just to give you all an example. Now, if you go and buy your, let's say, LED light bulb, did it? What do they write there normally? You go look at the package. There's one important thing they'll write. They write something like this. Okay, they tell you the power rating, but they do not tell you the energy because energy depends on how long they're going to use it. They only tell you the power. So therefore, if you want to work out the energy, then you have to figure out how long are you going to use it for. If you want to use it for 1 hour, that would be 3,600 seconds. And that will give you your answer in joules. Okay, all the appliances, everything, you have a power rating. Some also have voltage, some also have current, but power will always be there. Just check your hands. They should have a power rating somewhere. Okay, let me see. I think that's about all the formulas you need to know for now. Now, let's just do a quick one. I think you guys shouldn't be a problem. So I have this. This provides the voltage. So I have 6 volts here. Okay, this is 1 ohm. This is 2 ohm. This is 3 ohm. Do a quick calculation. What's the current in the main circuit? Meaning this one. 1 what, ampere? Oh no, of course not. Of course not. You're forgetting something. This is parallel, huh? So you have to use that formula earlier for parallels arrangement to work out the total resistance. It's not one.
Two point nine seven.
2.57. Let me see how you worked out first. No.
Oh, see, I add everything there, flip over.
No, hold on, where's my. Oh, you didn't draw the circuit line. You've got
It's
to.
either 2 over 3.
You've got to flip over this side first.
Yeah,
Then you add that side to this.
flip the make sense, so it's fine.
Okay, this. Where's the. You didn't write. So no problem, right? That means what did I write earlier? You notice this thing B there? You flip over and you need to flip over again one more time.
6 out of 5 is. If I flip it over, it's over 5, right? Because what I got was 5 out of 6.
Yeah, correct. Yeah.
And 6 over 5 is 1.
1.2.
Huh?
Oh no, 6 over 5 is 1.2.
Oh, yeah, 1.8. Yeah, 1.2, 1.2. So it's actually just 2.2.
Yeah, 2.2.
Oh my god. 0.2 of the 6 divided by 2.2 is 2.72.
2.72, right? Okay. Maybe do you get that? 2.72. No? Okay, come. Let's work out this one first. You work out one at a time, no? That means you work out this resistance first, this whole chunk. Okay, so this whole chunk will give you 1 over 2 plus 1 over 3. But you need to flip it back again. And you should get 1.2. Yes, but this chunk and this guy are in series, so you can add them straight away. Therefore, it's 1.2 plus 1. That gives you a total of 2.2. That's how I get it. Okay, so try not to be careless of it. But, yeah, just for you. This is a bit harder. Tell me, what is the power in this light bulb? What's the power usage in that light bulb? How much power does it use?
The voltage for that one also 6.
Oh no.
Oh.
6 applies to whole chunk.
Oh.
That. How was the power? And just to make things even more difficult for you, they ask you what's the power usage here. This one will be difficult.
It's only for that one light bulb.
Yes. He can apply either to the whole thing, then you have to consider the current and the voltage across the whole thing, or if you apply to the light bulb, you have to consider the current and voltage for that light bulb.
Oh.
Yes. So your question is it what? 36. No. You mean for this one, the first one?
Yeah.
No. No. Maybe you have to ask yourself, what's the current going through here? Do you know the voltage through here? Do you know the current going through here? You do. This current is going through here, it splits, right? But it joins back at this point and it goes through that light bulb. So the current through here is. Therefore, which formula should you use? Yes, correct. Because you know the current, you know the resistance, easiest is to use the first one. For the second one, this one, do you know the current through here? No. Why it doesn't split equally? Yeah, so it's not equal. This one is difficult. This one is difficult. You can provide that, yeah, because it's the one. Do you know the voltage in the second one? This one. One, They are saying this is 3. No, it's not. It's not. Yeah. This one is very difficult.
I don't understand. Second one.
Second one, right?
Yeah, I don't.
Do you know the voltage through here? You don't. You have to work it out.
Oh, really? You use the 6 voltage and you use the 1 given. Do you see that?
6 volts and then?
And this is the first one.
Okay. I tell you how I will do it. Now, this one here. Do you know the voltage? You don't, right? So I have to work it out. Okay, so for this one, just bear with me first while I'm working on this one. The voltage is IR. You know the I, right? 2.72, you know the R1. So the voltage is 2.72 volts here. Okay. Now the difficult part is this. Total is 6 volts. That means through this whole chunk is 6 volts. And this guy, the first light bulb here, took up 2.72 volts. Therefore, across here, if I put a voltmeter here, this voltmeter will show me how many volts? 6 minus 2.72. That would give me 3.28 volts. So this voltage will apply to this guy and this guy. Remember, these two are parallel, so they have the same voltage, and I now know the voltage is 3.28 volts. So what formula should I use here? What?
Then the power in the first one, right, is times. I thought it's different from the.
It's the first one.
I use the I squared times R. But here I use a different formula. I use V squared over R because I have found the V. I know the V is 3.28. And I know, of course, the R is given 3 volts, 3 ohms. And that will give me my power. Now look at it this way. If I redraw this for you, I redraw the circuit for you. This guy provides all the voltage through the circuit, 6 volts. This lamp took up 2.72 volts. So I have one big chunk of unknown stuff here, a black box. Where does the rest of the 6 volt go to? Here. So this chunk will be 6 minus 2.72, which gives me 3.28. Okay, and this chunk is this chunk here. Okay, so 3.28 volts applied across this chunk down there, but this chunk is in parallel. So the same voltage will apply to this and to this. So this one has 3.28 volts. This one also has 3.28 volts. But obviously the power usage is different. This is because this is a lower resistance. This is a higher one. That would be a more difficult question for you.
It will split into half, right?
Oh no, is it split into half or not? That's how she was asking already. Did the current split into half? Look carefully. Your current split here, correct? There's one branch going here, one branch going there. Are these two currents the same? No, why not?
Top one lesser resistance.
Yes. So you will have more current here.
Oh.
Okay, because the resistance is less. But of course, if you want to make things hard for yourself, you can go and calculate. I don't know whether your school will ask that or not. But her school has a high chance of asking that. Yeah.
Friends, all my friends wanted to go Bukit Panjang.
But
they got rejected.
Oh, so were they happy?
No, but then they got rejected. Then they're like, yeah, at least close my home, right? But our school, right, got a lot of problem, right?
Problem. You think the school doesn't have, they have their own problems too.
They got issue, attitude issue between people, not between the teachers and the student.
But among students,
yeah.
Okay, I can't. Me can follow. Hopefully, when it comes out, you can do it on your own. Oh, but you want to make things more interesting? Find out what these two currents. Yeah. Yes. So, what formula should you use to find the current? Yes. So you really have to remember all these formulas, and you have to be well versed in them. When to use which one? You never know, you may have no choice, right? Right, you may get pushed into people science. Yeah, your teacher will call your father. I think Jing Xian is really good. He has the potential to do well.
CMI.
CMI, really.
Not really CMI, but CMI.
Okay. But it's true. If you think your physics really CMI, then try not to take. But still, I still think that is the easiest among the three. But some people simply cannot see it. I mean, cannot follow. Yeah.
Me too. Okay. Why they make chemical compulsory? What is the hardest though? Then you have to do math also.
Yes.
If the math not good, then siao.
Yes, there's also graph as well for chemistry.
Maybe a bit.
Very little. Graph.
Maybe digestion has
Maybe what?
digestion.
Digest.
But imagine give me a last year paper.
Enzymes.
Yeah, the
Enzymes.
Question is the same.
Oh, those days are over. Rheostat. Oh, rheostat. Okay. Rheostat is okay, let me go to the question. It's a device that can allow you to vary the voltage.
Oh.
It's a variable resistor. That is how, oh, I got answers. Oops.
Wait, here is times
1, 2, 3. 3.
3.
Yeah.
1,000.
Yeah, you better remember.
Seem like kilogram.
It's the
Whatever. So it's all times 100.
yeah, times 1,000.
Oh, 1,000.
That's how you remember. Oh, kilometer, kilogram. That's okay.
What's the plus and minus at the X here?
Plus and minus. Oh, okay. Your school didn't mention plus and minus.
It's positive and negative.
Ah.
But this is the emitter, right?
They did. Okay, which question again?
6. Yeah.
5 you mean?
6.
Oh, okay. Now, first thing first, can you remember your primary school? This is your battery. Which side is positive? Which side is negative? Yes, positive, negative. So that means current will flow up on the positive side, right? Now, this is a device. And normally for most devices, you need to connect correctly. Positive connect to positive, negative connect to negative. You check ammeter, voltmeter, they will have a positive and a negative port.
Okay.
Mm.
Thanks, John.
Okay. Actually, that time I did show you the voltmeter or ammeter before, right? Last time I brought along, but maybe you can't remember. There's a positive out and a negative one. Okay. Come this one, I'll give you the answer for free. And number eight, just asking about number eight. For Singapore, it's 230 volts at home. At home. But you go to China, it's 110 to 120. So look up, if you let's say go to China and you bring some device there to use, it may spoil your device if your device is not suitable for that voltage.
The distance is I over V or C.
V over 5. That one you have to know.
12.
Okay, this one. Make sure you can do. But for you, it may come out also. It may. Now, the thing is, What is the current flowing through?
Oh, 应该改了个字。
Yeah, that would be the easiest way. Is it? Four. Current is four. No, no way, no way. You need to work out. Tell me, what's the formula to use?
0.002.
Yeah. Alright, is it 0.002? Hold on. This is the formula to use, right? Okay, voltage, there's only 1 volt, 6 volts. But resistance, to be careful, what resistance should we use? You measure what? Ampere? No, resistance in ohms. So current
0.001.
is amperes. I don't know whether you notice, are they series or parallel? These two. Yes, series. So I add the resistance together, but do you notice the K? K. All right, so therefore you have to write 3000 ohms plus 1000 ohms. So it's 6 over 4000. Huh? 0.0015. Huh? So that's the current. Okay, so once you know the current, can you find the voltage here? Yeah, you can. Then you use exactly the same formula. Right? So 0.0015 times 1000. Yeah, you have your answer now. Oh, Qingquan, this kind of question can come up for you. Yeah, it can. For her, high chance of it coming up.
I chose the center.
Oh,
She not that. She gave us one.
The current stays.
yes, because everything is in series. That is the trick you need to remember.
The pencil.
My pencil. No, I don't use pencil. Don't know. Some student never come past to me. I'll put it at the counter. I'll see whether anybody came.
Yes. Oh, by the way, don't you see that's all about that? Is it more of a standard?
Yes.
Oh, good question. It depends on how you define conductor. Come, let me just write a few things for you. Now, in theory, for secondary school, wires are perfect conductors. That means zero resistance. Okay, in theory, but in practice, of course, that's not true. How about this? What does this mean? Yes. Does it have resistance? What's the resistance? Asian
Huh?
ammeter, does it have resistance?
Maybe. One, two.
Okay, come, break down. In theory, zero resistance. Yeah, you don't want it to eat up any voltage, no? You want it to measure accurately. You don't want it to provide resistance to the circuit. In practice, of course not, if you have some resistance. But more interesting, how about the voltmeter? What's the resistance?
The resistance of the resistor.
No, resistance of the voltmeter. Yeah, it's infinite.
Oh, God.
That means what? No current can go through it. So by right, in this circuit, no current goes through the voltmeter, no? Otherwise, we won't measure accurately if there's a current going through here. All right, so don't go and split a current here. There's no such thing. No current goes through here. They are the perfect conductor in theory. The
ALC.
for 11, you mean?
Yeah.
Okay, ALC is less than the resistance of a resistor. Well, that's true, of course, right? Zero is less than the value, right? A conductor does not have any resistance. Not true. Is a light bulb a conductor? Yeah, otherwise, how is it going to work? Does it have resistance? So yeah, that's the thing. You have to be clear about your concepts.
Show myself.
Get number 13 correct.
So this is a fuse, right?
Yes, good.
Yes, one. I know what's a galvanometer. Do you know what's it's variable resistance. Got arrow. Yeah, got arrow is variable resistance. Let's see. C is C is fuse. Yeah, fuse. Yeah, got. So, together, this is because of and it seems that a lot. So, and we shall do something. I don't think it's very. It is yeah. So we have a very statement. We can use our regions. So we can know everything. How do we Yeah. How many is actually have? If you don't know the difference, how many that transformer. Transformer. The one that get transformed into car, lorry and the.
Rich man.
Transform the void into current. Or is it? How to transform the whole circuit?
Okay, come on, I give you the answer. Because no need to know followers.
So the galvanometer. What's that?
Galvanometer
Oh, galvanometer.
is a very sensitive ammeter. Yeah, it's an ammeter.
Do I put a G or A? Or GA?
GA.
Needed assignment. Oh, what does the transformer even do?
It changes the voltage from low to high or from high to low.
There.
Okay. And it doesn't work by resistance, that's the thing.
Is this not opposite physics?
Yeah, it is.
Okay. Good thing.
Yeah, okay. So how? All right. Okay, let's quickly go through the MCQs, try to get everything correct.
How to do the structure?
I thought only a few inside. Yeah, sure. Come, Jingxuan, number 1.
B.
B. Okay. And May, number 2. D for dog. Good. Of course, your questions, voice out. Rules that I think I told you already. It includes a variable resistor inside to change the voltage. Okay, I think number 4, I've told you to don't get it wrong, seriously. Number 5, Jingxuan. See, this like primary school question. No, not this one. Okay, number 6. Yeah. Jingxuan. D for boy. Good. Number 8, I think I told you that. Okay, number 9. This is the primary school question. Yeah. Jingxuan. Number 10. C. Okay. 11, I've told you. Number 12, I told you as well. 13, yes, both of you don't get it wrong. 14, Jingxuan. D for dog. Yep. Anyway, just a note in case May didn't hear us earlier. This is a fuse. Now let's go on. 15. Yep, May. See. Okay, good. Now, most of this, I don't think you have a problem. Some are primary school stuff. Resistor, variable resistor.
Why resistor so big one?
This one.
Yeah.
If you want,
yeah, my school very big set.
Because if you need a lot of resistance, then you need a big one.
Oh.
The bigger it is, the more resistance you can provide.
The big resistor is small. Also depends.
Depends how big the resistance is. If it's small, then it's small. Yeah. You don't want too large current running through the circuit. Okay, fuse, I don't think it will come out for lower sec, but this is the fuse which I shown you earlier.
Oh, it's the one that melts, right?
Yeah. I think it's in your syllabus, right? Fuse, is it? Yeah, if your current is too high, it will melt and then open the circuit. Used to, you mean primary school? Oh.
Primary school is the favorite subject of most people.
Science.
Yeah.
Electricity.
Yeah.
Oh, really?
The most heated topic, yeah. is adaptation.
Oh.
For my school lah, for my school.
Oh, okay.
For my class also.
Hmm.
My class was quite weird.
Oh, you know what's the most basic question? The water vapor.
Huh?
The water vapor.
Oh yeah.
You mean in the exam? Water weight.
It confirm will come out.
Yeah, it comes out every year. But for secondary, it has disappeared.
Because it water vapor away.
It has vaporized. Switch, better get it right. This is a primary school thing, huh? Stop, of course, better get it right. This is another primary school thing. Likewise for the rest, ammeter, galvanometer,
Oh, it's a G.
voltmeter.
Oh, come on.
Okay, so what's an electric current?
Oh, electric.
Yeah, make sure what is flowing inside. Something is moving inside, is electrons. This one you have to know. Why electrons? When you go to opposite, they'll tell you metals are good conductors because they have electrons, lots of free electrons inside. They can move around the metal.
Oh. Nature. The particulate nature of matter is physics or
Both physics and chemistry.
so it will still be better for chemistry.
Yes. Yes. Come, me. SI unit for current. Okay, and here, what's the symbol for current? Yes, how they represent current.
Oh wait, never mind.
Current is, you should know that. Mm. Junction, QC.
How should an emitter be connected to movements in series?
Yes, this one don't screw up. By the way, don't screw up in real life also. If you want to attach an ammeter, you better fix it in series. This is quite easy to screw up in real life. You can attach in parallel and it's going to spoil your ammeter.
I did that to my school's one though.
Then nothing happened.
Yeah. No, but it went from zero then it go down.
Oh, is it?
Yeah.
Okay, I guess the current is not that high.
It's me a bit of me the current.
You know what will happen if you do it in parallel? You know what will happen, right? If you attach your ammeter in parallel.
Explode.
Oh no.
It
You
can
want-
fire.
You can do calculation on it.
Oh, it go negative.
Let's say you use any circuit. Alright, let's say just this circuit. Then you stupidly go and attach the ammeter here.
Oh, it will spoil the whole thing.
Possibly, depending on how good your ammeter is. You know what will happen, right? Okay, this one not too bad because there's two ohms there. Still not too bad. But if I do it here, this would be terrible. You know what happened? What's the resistance of ammeter? 0. That means the whole current will go through here, no?
Oh.
And you know what's the whole current? Infinite current, Infinite, no? Because there's zero resistance, And if your ammeter is not robust enough, there's no breaker inside, it's going to spoil. Probably not, but it will definitely spoil.
Wait, if the current is stays, like something stays.
Yeah.
But then in parallel,
It will split that.
it will
It depends on, remember, it depends on what. Yeah, come, this one you have to get it right. I have this circuit. Oh, by the way, you better be a bit open-minded, Your parallel may not be obvious, right? This is still parallel.
Oh.
First thing, how does your current flow? From this positive end, it goes up, But here it splits into two branches. Then here it joins back together to become the same current. So I here is the same as I then. But does it split equally? No, it depends. Because if this is 1 ohm, this is 2 ohm. Tell me which side you have more current. The one through the 1 ohm lamp or the one through the 2 ohm lamp? Yeah. Okay, more current will go through the 1 ohm because it has less resistance. But of course, don't forget both lamps will have the same voltage because they're in parallel, but the currents are different. Imagine this one is, let's say, 2 ampere. Over here is 1 ampere. What is my I? This branch has 2 ampere. This branch has 1 ampere. Do you remember it splits, right? It splits here, right? It splits to give you 2 here and 1 there. Yes, so it's true. And of course, it joins back at this point, you get 3 again. This, you have to know these concepts. Where will be? I hope you can draw the diagram. Ammeter, oh, A for ammeter, obviously. Make sure it's in series. Plus and minus, no need. The what?
Just put the ones.
I don't know. Does your school need you to have ruler?
Ruler and pencil.
Oh, is it?
Technically, the circuit isn't easy.
Yeah.
Other than that,
Oh, is it? Yeah, it doesn't. Make sure you can draw something basic like this. Okay, no need to draw crocodile clip. What is voltage? But this one is not totally correct, but when you go to opposite, they are the different answer.
Go to opposite.
Okay, let's hope so.
Also.
And
B.
yeah, B and B, you should guys should know that. What's the connection like? Yes, parallel. Usually in real life, you won't screw up on this one because it's quite intuitive to fix it in parallel, but not in series. Okay, this one not a problem. Make sure you can draw it nicely.
Yes.
Yeah.
So complicated. Oh, must join the end.
Which one is at the end?
The wire, not in the middle.
How do you draw it?
Right.
Oh, it's okay lah. Doesn't matter. Doesn't matter. You want to draw pattern also okay. You know, like this.
in my school now.
Okay, potential difference. This one is I think it's quite stupid. It's the difference in electrical potential between 2 points in the circuit. Yeah, obviously. But like I say, when you go to upper set, you have a different answer.
Oh, yeah.
You didn't answer, right? Did you?
My old teacher told me that the definition of potential difference is not the same.
Same, huh?
Say the same.
Yeah.
But then my new teacher told me it's different. So I also think it's different because she said that.
But you tell them you're not going to upper set.
Oh, what is the electromotive force for?
Okay, but this you ought to know. When do you use potential difference? When do you use electromotive force? This one is for a power source. That means like a battery.
Oh,
Anytime you refer to battery, you don't, I mean, you can't call it potential difference, you call it electromotive force.
what potential difference is it? Appliance or the appliance?
Yes, for appliance. This one is for appliance or any component in the circuit. Like a lamp. But if you want to be very casual about that, both of them can be called voltage.
Oh,
The voltage of a battery, voltage of an appliance, voltage of a lamp.
why they ask what is the difference between voltage and potential difference?
Oh, you said that voltage is only can be used, is a general term, whereas potential difference only applies to component on the appliance. Okay, come. Let's go to the next one. Resistance, well, I think you should have an idea. Basically opposes current. Okay. Let's go on. Resistance. Symbol. Unit. Yes, that thingy. Omega stuff. What is effective resistance? It's basically total resistance. Okay, can be a chunk, can be the whole circuit, depending on the question. Because you're trying to consider the resistances of all the components together. So that present an effective resistance. Okay, it's quite fun now. When you go higher up, then you realize that even battery has its resistance.
Ashton's gonna like it.
I don't know. Come, Diksha, what answer do you get here?
22.
Yes, too easy. Better get it right. Okay, come check your answers. Make sure you get them right. You can't afford to get them wrong. My answers are on the screen. okay, if you get them wrong, yeah, you better work it out now.
96 and you can use calculator, right?
It's no more primary school.
Yay!
Okay, part 3 and part 4, make sure you get them right too. But number 6 is quite unusual. What are the 3 effects on electric current?
So,
We can cook food, makes us feel warm or cool, or powers our appliances.
It's more general than that. Okay, but I don't think this kind of question will come up because it's a bit high level.
see.
Electricity is break down the water into.
Yeah, break down something, not just water, but can be something else.
Then electroplating is.
An item has a coating of metal building over on the surface.
Oh.
Okay, so these are the 3 general answers. Heating. Oh, by the way, since you're on to this, I shall add on. Now, in general, for heating especially, the higher the resistance, the more heating there is, or the more heat is generated.
Oh.
So in other words, if you have a light bulb, a light bulb, filament light bulb, this kind, the old kind. All right, this one has a high resistance. Yeah, so the electrical energy is converted to heat and light.
But the new one, right? When you touch it, it's also very hot.
The new kind, LED.
LED.
Yeah, because you can't run away from heating effect. As long as you have resistance, it will heat up. Okay, this one, count me. Yeah, that's all. 0.05, huh? Okay, didn't work this out. Is it correct, Xinjian? 0.05 or 25.
Close to.
Yeah, 0.25. Was that the last page? Okay, someone, but I didn't give it to you.
Oh, is it a no?
Okay lah, the others are primary school questions.
Okay.
Yeah, for your school, anything can come up. That's the tough part. It can be very hard. Especially when you don't recognize whether it's parallel or series. Let me see. Any difficult question to show you. It's a power question that you should be worried about.
Oh.
Yeah, for her, it's a power question.
Oh, power come out from my school.
Power, not for lower sec. Not for lower sec. Yeah.
But they got teach too.
Huh?
But not the formula.
No formulas, right? Yeah. Then it's okay lah. The power only come out for that. Calculating the cost of electricity. It will come out for that.
Okay.
Essays are not, I won't say it's essay, but just long questions requiring long answers. You don't mind? It's not that bad.
But if will physics question be short or same?
Usually quite short. There's no long question.
But the steps you have to do is long, right?
And yeah, it may not be so straightforward. It's not long, it's not straightforward. You don't know what step to take. That's the difficult thing. Show the physics question. It seems okay.
Oh.
He somehow he's quite good in electricity. He's okay.
Huh?
Yeah, that's always the case, right? Isn't it? Let's do the simple one. Let's say your digestive system.
Oh, it's for nutrition.
Yeah, they don't quite digest. I mean, they do lah, but the chapter is called nutrition. Yeah, it sounds
It's so fancy.
so fun.
FCE.
Yeah, it does.
Like they never put like
Okay.
whatever enzymes.
They will look at FCE.
Yeah, maybe I see now.
You just wait a while for it to load.
Oh, my FC was last semester. Yeah, last semester.
Why he the written exam?
I used to have my written exam one.
I didn't take right up here because I was out for competition.
Oh, so actually did your power paper. That's why I had to remember.
They allow you to skip one.
Yeah.
So good, right?
But I didn't take the written on the practical.
Oh, okay. Then the marks are?
It was valid research.
It was what?
Valid research.
Oh, okay. So the marks are, I mean, it won't be computed as your final final results. Huh? Okay, so this is physics. Let me see. It's your brother's finger. Something like this.
But
This physics.
Oh.
Yeah. They'll give you a story,
What's this?
pressure.
So complicated.
Okay, and then the simple one.
Absolutely. Get the one you wrote.
That's the thing, you don't know. Sometimes you don't know what to write. Oh no, this is a text version. There's no calculation.
Oh,
so
explain your.
You have to explain. Yeah, for 2 marks.
What say? You have to write so much.
Yeah, this one is the reverse.
So can you show us the answer? Remember this was.
Actually, let's see. Up here, right there.
Oh, so never mind.
You must know what to write. That's the thing. Because it's quite short one, not like bio. Bio will have long answers. For bio, the question is short, no, but the answer is long. Let's see.
It's a bit like short answer but long answer.
Okay, let's see. Bio still loading. Awesome. All the answers are got graphs.
Graph.
Nothing. This is like a primary school graph, right? But just that they introduce enzymes. What? Which one? Ileum.
Yeah.
Ileum is the first part of your small intestine. No, not the first part. Second part.
You also got spleen.
Where?
You also got a spleen to first, second,
Yeah.
and last.
Yeah, got. So then, let me see. Do I have an answer here? No, this one I didn't put the answer yet. Where is the one with answers? Let's see. This one,
Maybe it's just the hair from bristle, so it looks very long.
Then state 3 functions of the organ label E. They will actually ask about this one. You better know what it is, huh? Yeah. Okay, 3 marks. This one not too bad.
Oh, wow.
No, but here they give you all the answers. Any 3 is about 10. No?
So are they gonna teach you 10 and then they test you 3 or
Yeah.
5 or whatever?
No, they will test you any of the 10. So you got to know all this.
What's even worse? They give you all the easy one.
Ah.
And then you cannot remember the hard one, right? Then you're done. Then they ask you, give 3 more examples of what does the liver do? Oh, they say all that.
Yeah. Okay, yeah, this is a long question. 5 marks is long.
Examples in your answer.
Yeah.
Describe the roles of enzymes in human digestion.
Oh my God,
Give example.
It's 1 minute.
Basically, then it's nice just the one you write about.
If you
They give
didn't,
you another paper that you write.
no. The 5 marks is long, no? So yeah, okay, like that lah, not that bad lah, huh? So make sure mention speed up reaction.
It's broken down. Oh, you have to write down the whole thing.
Some examples do you give?
Okay,
Examples.
they are quite open. That means examples must be plural, so at least 2. But of course, the other points must have enough. You must have 3 points and then 2 examples.
Your mix enzymes.
Is that what?
Is that examples for the enzymes or is it?
No, this is just a general statement.
Oh.
This is an example. Starch is broken down into maltose.
Or more
Hmm.
example.
Then they give you a second one. Maltose is broken down into glucose by maltase. But this guy, whoever wrote this, is very kiasu. He add a few more at the back. Okay, broken down into amino acids by erepsin. Then lipases break down lipids into fatty acids and glycerol.
So what is hydrolase enzyme?
That means they perform hydrolysis reactions.
Hydrolysis. Is it reactions that are
That means
in water?
they need water to react. No, like all digestion reactions, they need water, even though it's not mentioned.
So the enzymes are all hydrolysis.
I thought you have learned that. Yes, you did. Remember your glucose or sucrose. This is formula for sucrose now. C12 H22 O11. This is sucrose. What it does it break down into?
Yes. H.
Yeah, by sucrase, but what are the products? Yes, it breaks down into glucose and what? No.
Wait.
Oh yeah. Fructose.
Yeah. Okay, so I think you need to remember this, if I remember correctly. Then formula for glucose, C6.
12.
O6. Fructose, good news, same formula. But do you notice there's an imbalance?
So you have to balance them out.
How? Where?
Yeah.
Yes, you need to add a water here to balance it.
Oh.
So that's why this is called a hydrolysis reaction. Because you need water and actually water breaks up. Oh, I mean, go and count if you're not convinced. Okay, fine. Yeah, so is this easy? I don't know. What do you think? Okay.
Better than the physics one. You write all over the place. Whatever F, A, F.
You must know what formulas to use. That's the thing.
Same. Does Angel take physics or bio? Which
All three, right?
no tuition.
Tuition or physics.
See and chem.
Yeah.
Oh, she don't take bio lah. The bio can
But I don't know. It seems so.
ah.
Yeah, all this all you have to describe, write story.
Wow, 3 marks.
Yeah, 3 marks.
For this one.
Describe. So yeah.
It goes into the star mark, then blah blah.
Questions.
Are there what?
Answer questions.
Lesser question.
Yeah, since each question is worth so much.
Yeah, there are. I think there are 1 mark questions, but not in this section.
You mean like in the whole paper, it's there lesser questions?
Yeah, this one.
Because the marks are very big.
Yeah, this one. This might sure get one.
I like the question.
Wait, the nectar of the organ. What to do? Oh my god.
So you make a guess, A, B, C, D, E, F, G.
I guess I guess is.
You guess,
Wait, what is F in the what is F? Check in Zoom. Gallbladder.
What is F? Then?
Gallbladder.
No, you must recognize this gallbladder.
Oh, okay, it's a bit different from the one you got.
Oh, it's
E.
Huh?
E or C.
E or C, A.
causes.
Oh, might be even B.
There's only one, of course. C.
Oh,
Yeah.
speech almost.
No.
The what?
Esophagus. Oh, sorry.
Esophagus. Yeah, it doesn't do much. You just push the food down. That's all.
Transport.
Yeah, they won't. They only ask. They can only ask about esophagus. What are the muscles inside there? So, how do they work?
Oh,
That's all. F. By right F, you can even answer yourself and describe its function. Yeah. This one is the lowest question. Yeah.
Say wow.
Mm.
Mouse device. That's it.
Yeah.
Then you get the.
Yeah. So it's some are easy, some are not. It's the section B. Section B is the tough one. Minimum 3 marks, 4 marks. Yeah, 5 marks. Section B will be the long questions. So they can write long story like this. What are the enzymes? What happens? What are the products? But now, okay lah. This is a lot old syllabus, so they write more. The new syllabus is shorter. They don't. The content is less.
is there a format?
Format.
Yeah.
Something like this. There is like what are the reactants, what are the products, what's the enzyme, what are the conditions, which part of the body. I mean, in general, that's correct. In general, yes. You know, I mean, you need to know, write out all the enzymes, right? All the products and the reactants, the conditions, which part of the body. Okay. Any final questions for today? Okay, then, yeah. See you next week. Bye. Okay, bye.
Sure.
Oh, ayo, so many questions. Mm, you have time now.
I want to like,
Oh.